Sweet. So we're doing notes on ellipses, and this is under our section on conics. And the definition says an ellipse is a set of all the points in a plane, the sum of whose distances from two distinct fixed points called foci, okay, is constant. The constant is equal to twice the length of the semi-major axis. And let me just kind of draw a picture of what they're talking about. Remember how we talked about a circle? It was all the points that were equidistant from this one center. Mm-hmm. Okay, ellipses is all these points that are equidistant from these 2 points. Okay? Okay. So we're going to talk about an ellipse with the center at 0, 0. So basically, if we're looking at our x and y axis, our center is going to be at the origin. Okay? Kind of like when our circle was at the origin earlier. Okay? So your HK in this instance would just be 0, 0. All right. Here is your general formula for an ellipse. It's going to look like x squared over a squared plus y squared over b squared equals 1. The key features of an ellipses is you still get your x squared, y squared like you do in a circle. The big thing here is you have this new thing called an a squared and a b squared, and it equals 1. When you're looking at a hyperbola equation, it looks almost identical. The difference is it's not the sum, but a difference. Okay? So, but for right now, we're looking at the sum. All right? And it's always going to equal 1. Now, the center here is going to be 0, 0. And this is going to have your major axis here is the x-axis. And what does that mean? Okay, when you have when you have a circle and you have one center, it's exactly the same distance in the x direction as it is the y direction. It's the same distance from that point. Okay, when you have a major axis of x, it means your ellipses is going to look more like a football on its side than standing on end. Okay, the longer of the two is going to be horizontal. Is that kind of making sense? So I'm going to draw a little bit of a picture up here of one with an x major axis. Okay, it's not perfect. It's going to look like an Easter egg. Yeah. Okay. So this has what we would call an x major axis because the x is longer than the y. All right. So this distance here is a. All right. The distance from the center to, and this is actually called a vertex. This end here is called a vertex. All right. Now your minor axis would be the one that's not as big. Okay. In this case, it would be right here, and they call this b. Is that reasonable so far? Okay. Now somewhere in between the centers and the vertex, you're going to have your focus. I'm going to put focus here and a focus here. And I know my picture is not to scale or anything, so get over it. But yeah. Your distance from the center to the focus, this distance in here, is your C. All right? So from your center to your focus is C. Now, there's a formula that you're going to want to know to be able to see how A, B, and C relate to one another. If you have a horizontal major axis, that means that this A square is going to be bigger than this B square, okay? Whichever number is bigger underneath, that's the major axis you have. Okay. But we're just for right now saying A is bigger than B. We're saying this is going to be larger. So since the number under it is larger, it's going to be a horizontal major axis because it's under the X.
Can you ever have the equation in the form of decimals?
We don't usually put this in decimals at all. Okay. It's almost always in fractions.
Good.
Okay. So let's see if I've got this right now. We've got our center at 0, 0. We have this right here. This is the semi-major axis length. This whole thing is my major axis. From vertex to vertex is my major axis. The major axis is 2A. Okay? From one vertex to the center is going to be my length of A. Okay? This would be my minor axis from up here to down here. The length of that would be 2B. Half my minor axis would be B. The length from the focus to the center is going to be my C. What you need to know in order to be able to relate A, B, and C together is that C is equal to the square root of A squared minus B squared. Okay, we are still in that first column on page 1 on our ellipses, and I just kind of wanted to go down. Our center's at 0, 0. We talked about our major axes being this way, our minor axes being this way. What we didn't talk about was the location of the focal points, or the focus, the foci. This one is going to be at -c, 0, and this one is going to be at 0, c. This one right here. Those are the two, no, not 0, c, but c, 0, my bad, because it's all on the x-axis there. All right, and then the vertices are located here. This one here is at -a, 0, and this one is at a, 0. Now, depending on the books that you talk about, some books will say that there are 4 vertices, which is what they say. They consider all 4 of these points vertices. I only consider the points on the major axes vertices. But if they ask you for the vertex on the minor axis, then you know what they're talking about. Okay, so it really just depends on how they're viewing it. We are going to look. In my notes, I have this whole thing labeled at the bottom, so where it says looks like, I hope you have this drawn in. Okay, and now what we're going to do is we're going to do the same thing for our next column. And so let's look at that. And this is going to be different only because it's going to have the x squared over b squared plus y squared over a squared equals 1. Now the only thing we did was we changed up the a and b here, where they're located. A is still bigger than b. This picture no longer applies. Why? Because the larger number is going to be under the y squared, which means I have a vertical major axis. So we're going to draw that. You can put that in the bottom of your second column. So I'll kind of try to draw an ellipse here. And there's one there. Okay? So basically it's going to be the same thing kind of turned on its head. All right? This one still has a center at 0, 0. Here's my center, and it's still located at 0, 0. This right here, this distance down here now, is going to be A. All right? It's my vertical major axis. My minor axis now is the horizontal one. That's going to be B. Let's see. What do I need to find out? Oh, I need some foci on there, don't I? Okay, let me put those on there. So they're going to be somewhere in here. There's going to be a focus, and there will be a focus. Together they're called foci. Let's see. What am I missing? Oh, the distance from the center to the focus is the length C. Does that even look like it could be correct? C. 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 Exactly. We want to find our vertex points and our focal points. So right down here at this vertex, my x didn't change at all, so it's going to be 0, but it's going to go down -a, and up here I'd have 0, A. And then for my focus, it's basically the same thing. This one is going to be at 0, -C, and this will be up at 0, C.